Momentum is the product of the mass of an object times velocity. The equation for momentum is mass times the change in velocity, or P equals m change v. A 100 kilogram quarterback is going 5 meters per second. Calculate the momentum of the quarterback. To solve this problem, you find the mass of the object, which is 100 kilograms, and multiply it to its velocity, which is 5 meters per second. After doing this, we find that the momentum of the quarterback is 500 kilograms times meters per second. Impulse is the product of force and time interval through which the force acts. Also, impulse equals the change in momentum. The equation for impulse is force times time. Force times time also equals the change in P, or momentum. To help understand impulse, we'll solve this problem. Calculate the impulse when an average force of 10 newtons is exerted on a cart for 2.5 seconds. First, we find the force, which in this case is 10 newtons, and then multiply it to the time, which is 2.5 seconds. When we do this, we find that the impulse is 25.
Conservation of momentum states that momentum before is equal to momentum after. It cannot be created or destroyed, it can only be changed. P before equals P after. Now let's try a practice problem. A 1.5 kilometer ball moving at 8 meters per second south strikes a 2 kilometer ball moving at 3 meters per second south. If the velocity of the 2 kilometer ball after the collision is 4.5 meters per second south, what is the velocity of the 1.5 kilometer ball? To solve this problem, you set up an equation where P before equals P after, and you find that velocity equals 6 meters per second. Elastic collisions hit and bounce. There is no deformation to the object, and heat is generally not generated. Inelastic collisions hit and break. There is deformation to the object, and heat is generally generated. Let's do one more practice problem. If you drop a flower pot on your head and it breaks, what kind of collision is it? If a basketball hits you on the head and bounces off, what kind of collision is that? Problem A would be an inelastic collision, and problem B would be elastic. Thanks for watching this video by Jamie Kiefer and Robin McNaughton.